This video covers everything we did in class today in 8th grade honors math. We spent today focused on reviewing what it means to solve an equation and how to solve 1, 2, and multi-step equations. Make sure that you've opened up today's ClassKick, which you'll find directly above this video in the Tuesday folder, so that you can follow along with these notes. Our first learning target says I can explain what it means to solve an equation or find the solution to an equation. In the hanger diagram below, the square equals, we're going to call the square A. I'm going to make my text smaller so that it fits. And we're going to call the triangle B. I'll make the text that I'm typing in here in red so that it's really clear to you what you need to add to your guided notes. I'm happy to print these for you in your return as well. We can represent the diagram with an equation, and we know that our equation is A plus 2B because we have 1 square A plus 2 triangles B on the left, and then on the right side we have 5B, and that's what we have on the right, 5B's, 5 triangles. So what we talked about in class is that we can simplify the equation on a picture, and we can also simplify our equation using inverse operations. So here's how we can think about this. If I cross off 2 triangles from the left, and I want to keep my hanger balanced, I also need to cross off 2 triangles on the right. What I'm really doing here is I'm subtracting 2b from both sides of my equation. I'm getting rid of 2 triangles or taking away 2b. And so I'll draw a nice neat line underneath my equation, and you can see that I end up with A equals 3b. I've simplified my equation, just like I simplified my picture, by crossing out those triangles. The key takeaway here is that when we change one side of an equation, so if we do something to one side of an equation, is what you've often heard me say, that means that we must change the other. And more specifically, we must change the other in the same way. So for example, we cannot take away a square on the left, or we'll say a triangle. We cannot take away a triangle on the left without taking away a triangle on the right, and still expect our hanger to stay balanced. So whatever we do on one side, we have to do on the other. That's how we keep our equations in balanced. The goal is to isolate the variable. And what that means is to get the variable by itself to determine the value of the variable, and that just means what the variable is equal to. So we're trying to determine the value of the variable that will make the equation true. Trying to figure out what number we could replace with the variable. And you can pause this video at any point to get these notes. I'm going to move on to slide 2, but you'll probably need to pause. So learning target 2 is I can solve a one-step equation. And one-step equations are something that we've been over quite a bit. We know that the inverse operation of addition is subtraction. The inverse operation of subtraction is addition. The inverse operation of multiplication is division. And the inverse operation of division is multiplication. If you need an example of how to solve one-step equations, you can take a look at today's notes, which are posted in Tuesday's main folder. For the sake of time, I'm not going to go over it in this video. The important thing to know is that to undo part of an equation, so for example, to undo multiplication, we need to complete the inverse operation on both sides. So example, if we were undoing multiplication, we would need to divide both sides by the same number. Now, slide 3 is where we really start to get into two-step equations. And I was saying today that two-step equations isn't the most accurate label for this because we really are talking about equations that require more than one step. And sometimes that'll be 2 steps, but the phrase multi-step equations might be a better description for this. So for example, let's take a look at the first equation here. Our goal is we want our x's on one side and our constant term, and that's just our numbers, on the other side. And so when we start to think about solving this equation, we're thinking, well, what can I do to both sides that's going to make x only appear on one side? Well, I can see right away that I can add 2x on the left. And if I add 2x on, or I should say I can add it on the right to get rid of negative 2x. And so if I add 2x on both sides, and I'll draw a line underneath for separation, but if I add 2x on both sides, I end up with 6x plus 9 is equal to negative 3. And so now I'm getting closer to just having x all by itself. I can see, okay, I'm going to get rid of 9 on both sides. And if I do that, if I get rid of 9 on both sides, then I'm going to end up with one side that just has 6x. So 6 times some mystery number is equal to negative 12. And now things become a lot simpler, because at this point, to solve the equation, all that I need to do is divide. And I'm going to write that in with a marker because I don't have a good way to draw that, but I'm going to divide both of these sides by 6. So I'm dividing by 6. And if I divide both sides by 6, I end up with x equals negative 2. Now, we're not going to solve the other two equations all the way through, but what I want to show you is that sometimes there's a different first step. In this equation, before we start making moves on both sides, we can simplify the left side. And here's what I mean by that. On the left side, we've got 9 minus 2. And so before we even start doing the whole solution, do things to both sides situation, we can say 4x plus 7 equals negative 2x minus 3. And that's just a whole lot simpler than if we tried to deal with 9 and 2 separately. And then similarly, in the last box, again, before we start making moves on both sides, we can distribute the 3 on the right. And what that looks like is multiplying 3 times x, so 3x plus 3 times 5, which is 15. And now we have a much simpler equation to solve. So the key takeaway here is that our goal is still to isolate the variable. And this almost always involves combining like terms, so putting x's together, putting whole numbers together, by doing the same thing to both sides of the equation, right? And you're going to hear me say that so much during this unit, doing the same thing to both sides. And oh, it already says to both sides, doing the same thing to both sides of the equation. Now, before we start making moves on both sides of the equation, what we want to do is we want to make sure that both sides are simplified. And so, for example, in this long equation that I've put here, we could add the x terms on the left and add the whole numbers on the right before we even start solving the equation. Those are some of the things we could do just to simplify, right? And again, you can pause me at any point. This is a video. I know I'm going a little quick, but that's because you're able to pause. So if you have been absent, what I would like you to do is skip to slide 5 next, or I'm sorry, slide 6. And on slide 6, directions, solve 5 of the equations on slide 6. So you only need to worry about notes on slides 1 to 3 and this slide. And that kind of gives you a bite-sized assignment to take care of. Once you've finished slide 6, you are good for today. Just make sure you take a look at today's homework as well, which is a late work catch-up, and it's all explained at the top of our Schoology page. If you have any questions, just send me an email.